Dr. Jingbo Louise Liu from Texas A&M University, Kingsville. Today we are going to discuss experiment number 6, weak acid analysis of household vinegar. One of the weak acid is called acetic acid. We are going to measure the total concentration and then determine the ionization constant of this weak acid, acetic acid, and then determine the molar mass of a monoprotic acid using pH meter. The objectives for this experiment are threefold. You are going to determine the ionization constant Ka of this weak acid. Acetic acid is also known as a monoprotic acid. The second objective, you will calculate the molar mass of this weak acid, acetic acid. The third objective, you are going to learn to use a pH meter to measure the concentration of hydronium. In other words, you are going to use a pH meter to measure the pH values. About this pH meter, I want to show you two different diagrams. Actually, this pH meter is completely showed you a digital pH meter. So in this pH meter, you are going to see a little probe. So over this side, this is your probe. You place it into the aqueous solution. For example, you measure the pH value. A pH meter is an electronic instrument used to measure the pH of an aqueous solution. A very typical pH meter consists of a special measuring probe. Usually is the glass probe, and this glass probe is connected to an electronic meter, so which you can use to measure and display pH readings, such as 6.95, that's your pH readings. Use the pH meter requires two major steps. The first one is called calibration of your pH meter. The second one, you're measuring your pH value. About the calibration of pH meter, usually you are going to use buffer 4, buffer 7, buffer 10 solutions for calibration. You are going to do this. Number one, you are going to select the pH mode and set the temperature control knob to 25 Celsius. You are going to rinse the pH probe, or the electrode, use DI water, deionized water, and blow dry using a piece of tissue such as CHEM wipes. And then place your electrode in the solution of pH 7 buffer, usually from high pH to low pH, and then allow the pH reading to be stabilized. Allow your display to stabilize, and then read your pH. So this pH, you need to read it, and this calculation we call the calculation 1. pH 7 is your calibration 1. Now remove your electrode or that glass probe from the buffer and rinse your electrode with DI water again, dry it using a tissue. Then place your electrode into the solution of buffer pH 4 and allow the reading to stabilize, and then set the display read to the calculation 2, adjust it to pH 4, and then remove your electrode from the buffer solution. Rinse it, clean it up, and then dry it. This pH meter is ready for you to do the measurement. Measuring the pH, you are going to follow these 4 steps. Step 1, make sure your pH meter is set to pH mode, and you adjust your temperature to the ambient temperature. Normally our temperature will be 25 Celsius. And step 2, place the electrode into your sample of interest. The pH solution appears in the display. The pH value is going to show you. You are going to read that pH value recorded in your notebook. And then the fourth step, you are going to rinse the pH electrode. Always make sure place it back in the storage solution. Place your electrode of your pH meter in the storage solution. Do not leave the electrode dry in a dry condition. Always again allow the display to stabilize before taking your readings. In our class, we are going to determine the household vinegar Ka value, molar mass. Possibly you are going to do a little bit more than this. So I showed you one example about the titration using sodium hydroxide to determine the amount of your acetic acid in your household vinegar. Normally the household vinegar is 3 to 5 mass percent of the acetic acid in solution. In this case, you are going to use your sodium hydroxide or strong base to titrate your weak acid, acetic acid, CH3COOH. You are going to determine the end point. So when you are learning this determination of household vinegar, what you want to do, you want to determine the mass percent, you want to determine the moles of your sodium hydroxide, therefore you determine the moles of your acetic acid based on your balanced chemical reaction. So your plan to solve this issue, so you are going to write it down, the balanced molecular equation, total ionic equation, net ionic equations. And you are going to from there determine the amount, moles of sodium hydroxide and moles of your acetic acid which is existing in your household vinegar. So this essentially showed you a very brief plan how to write it down, the balanced reactions. Oops. So about this acetic acid, household vinegar, how we are going to determine what we need to know, such as determine the moles. You are going to learn a new method before you learn the titration. So you have your burette, you place your standard solution into your burette, and then you place your analyte, in this whole case is your household vinegar, in your Erlenmeyer flask. And then you are going to do the titration. So your titration curve will be using the pH for your household vinegar as your y-axis. You are going to measure the pH values. And you use the volume of your sodium hydroxide standard solution titrant as your x-axis. In this case, we are going to pay attention to something we call the half neutralization. Half neutralization is the midpoint of your titration. For example, in order to neutralize your acetic acid, you need sodium hydroxide with a known concentration, 40 milliliters. You need 40 milliliters. This 20 milliliters is called your half neutralization. At this point, you have a special phenomenon. Your concentration of acetic acid and your acetate, acetic acid, weak acid, and its conjugate base, they have equal amount. At this point, your pKa and pH, they are the same. pKa equals negative logarithm of your Ka. Ka is the ionization constant value of your acetic acid. So this half neutralization is important. The reason is you are going to eliminate any deviation from this reading of the color change, from this slight over titration. Again, this lab, you are going to learn something called half neutralization. At half neutralization, you have these two key points. Number one, amount of sodium hydroxide is the same amount of your acetic acid is the same as your acetate, and your pH is the same as pKa. In this case, let's do a little calculation. So I have an example for you. You are going to measure 1.463 grams of your acetic acid. You are going to dissolve this in 50 milliliters of distilled water. You prepare a solution, and then before you perform this acid-base addition, make sure proofread your variables. Make sure your burette is calibrated. Make sure there is no damage. Make sure there is no leaking. And then from the burette reading, you are going to set your initial volume of your standard solution, sodium hydroxide, at 0.00 milliliters. And your final reading, you are going to perform titration. The final reading, you read it by yourself. In our case, so assume your final reading is 25.45 milliliters. Your concentration of your stock solution of sodium hydroxide, which is 0.958 molarity, moles per liter. What I want everybody to do, I want you to calculate the moles of sodium hydroxide and the moles of acetic acid at the end point of your titration. End point meaning at a certain point you are going to stop titrating. At that point, your color of your pH indicator, your indicator changes color in this lab from colorless to pink. Make sure it's a light pink. At this point, you are going to stop your titration. First of all, what's your plan? In order to determine your molar mass of your acetic acid, you need to calculate the moles. You know these grams. You measured it physically. You measure the grams. You want to calculate the molar mass. You need to determine the moles, and then you can determine the concentration as well, because you have 50 milliliters. Your plan is write the balance equation. Make sure your reaction must be balanced, and then you determine the moles of your sodium hydroxide. You also can determine millimoles. You don't have to convert it to moles. You can determine millimoles by using milliliters multiplied by concentration. If you want to determine moles, make sure convert milliliters into liters. And then at the end point, you are going to correlate the moles of your hydroxide, sodium hydroxide, to the acetic acid. In our case, sodium hydroxide and acetic acid, they are equal to each other at the end point. This is a 1:1 molar ratio. And then you calculate your molar mass, from these grams and moles. And then molar concentration, you use your moles divided the volume by liters. So here is our solution. First of all, balance your reaction. CH3COOH reacted with sodium hydroxide, produce sodium acetate and your H2O. So your moles of your sodium hydroxide equals to molarity times by volume in liter. So you have your 0.958 moles per liter times by 0.02545 liters. You determine your moles. So you have your liters. And then moles of your sodium hydroxide is the same as the moles of acetic acid. And then in your case, you are going to calculate your mass of your acetic acid based on the concentration. And then you use the mass divided by moles. Mass divided by moles give you the molar mass of the acetic acid. Molar concentration equals to the moles divided by liters. You have your 50 milliliter converted to 0.05 liters. Therefore, you can determine your concentrations in moles per liter. And then also, so you can determine your Ka for this acetic acid. Again, you have your you already determined your amount of concentration. What you can do, you want to determine the molar concentration of you calculated the molar concentration already from this previous slide. You determine the molar concentration, and then you are going to calculate your Ka. Determine the ionization constant of your acetic acid. How do you determine it? You are going to construct and something we call the RAS table or ICE table, initial change equilibrium, or reaction initial change equilibrium. And then you are going to determine the Ka by using this RAS table. So here is our solution. So you write down your balanced reaction, sodium hydroxide. You balanced your chemical reaction, acetic acid, which is going to be break down to hydronium and acetate. And the acetic acid reacted with water. Be careful with this water, which is liquid and solid when you calculate the Ka or Kb. So this value is not going to be considered in your Ka expression. You set it up, your initial. The initial is what you calculated. You calculated from your previous example. And then change, you assume the change is X. For your reactant will be negative X. For your product will be positive X. For your product will be positive X. Initially, your hydronium, you have 10 to negative 7, which is resulted from your water auto-ionization. This number turns out to be negligible. This 10 to negative 7 can be negligible. Initially, you have 0 as acetate. And then at final, you have, because your change is positive X, at final will be 0 plus X. This final refers to the equilibrium point. And then your acetic acid, it will be your initial minus X. Water, do not consider it. Your hydronium will be X plus 10 to negative 7 is approximately the same as 7. The second approximation, if your Ka is smaller than 10 to negative power 2, usually this X is negligible. Otherwise, X cannot be negligible. In that case, you are going to use the quadratic equation to do this calculation. And then what you are also going to do, you replace these numbers into your Ka expression. So put this what we measured from your pH, this hydronium into your equation, this acetate into your equation, and this acetic acid concentration into your equation. So therefore, you calculate your Ka. So our case, you measured your pH value, for example, is 2.53. That's your measurement. You measured the pH value is 2.53. you calculate your hydronium based on 10 to negative pH. So in this case, your hydronium concentration will be equals to 10 to power negative 2.53. Calculate your hydronium concentration and then replace these values into your Ka expression. Your Ka expression for this acetic acid dissociation equals to your hydronium concentration times acetate concentration divided by acetic acid concentration. You know this X values, which is you found it, you measure the pH and then you calculate the concentration. And then that's your initial, you assume this X, this 2.92 times 10 to negative 3 compared with 0.48 can be negligible. You determine your Ka. If this X is not negligible, make sure you minus X. You use this expression to determine your concentration of your acetic acid. I do have one more example for everybody to study. I will leave it for you to further explore. And in this lab, I strongly suggest doing the titration for 3 times, read your values accurately. And I also advise our students virtually prepare a standard solution for the next experiment. At this point, I'm going to conclude the lecture. Thank you so much. Stay safe and be happy.